And we're back. Welcome back, everybody. So, again, let me remind you that the quiz is tomorrow. Quiz is tomorrow. Many of you need a really good grade on this quiz. Number U15. Get your grades up. It's pretty much your last shot, this quiz, this next test. Pretty much it. So, fair warning is where you're at. All right. Take a look at number one here. Now, again, I'm going to be posting this video. Where can this video be found? This can be found homepage. Well, it's going to be on the assignment that's the same link as yesterday's because I want it directly below the link for this worksheet. So if you want to print yourself out a new one, whatever, you can do so. So if you go to the assignment still linked in from yesterday and just space down a couple, that's where this link is going to be, okay? Obviously, if you're already watching it from home, you've already found the link. All right, so square root of 200. Square root of 200 here. Break it down. That's 2 times 100, 2 times 50, 2 times 25, 5 times 5. Okay? So that means that this is a 1, 2, 3 2s, 2 5s. Buddy, buddy. So we've got 2 5s and 2 2s that are coming out. What's the number on the outside going to be, Nathan? A 10. Good. Yeah, remember only one comes out. So 10. Radical 2. Questions on that one? Now, if you had done the other method, what perfect square can divide 200? 100. What's the square root of 100? 10. 10 radical 2. Okay? Oops. Flip those. The perfect square is always the one that comes out. Yeah, just like the ones with the buddies always come out. The perfect square always comes out. Okay, 28. Let's stick to the factor tree method because I think 90% of you are going to be using that method. All right, square root 28. 28 is 2 and 14, which is 2 and 7. So square root of 2 times 2 times, whoops, turn that into a 7. All right, buddy up with the set of 2s. 2 radical 7. There's my answer. Pretty simple, right? There are going to be some simple ones like that where you just have to straight up do the factor tree, bring a number out, you're done. Now, remember what happens when we have a number out front? Well, in the end, we're just going to multiply with that number. Let's take 27. That's 3 and 9, which gives me a 3 and 3. Now, remember that 6 has to stay outside, right? We're not going to break down that 6 or anything. That's just got to stay outside. And then when we buddy up, that 3 comes out. And what's the total number on the outside? What's the total number? 18. 18, yeah. The 6 with the 3 on the outside becomes an 18 radical 3. And there's my answer. Okay? Any buddies that come out are going to multiply with that thing on the outside.
Why is it? So it's basically like you divide the 27 by 3 and then multiply the 6 by 3.
27 is a weird number. 27 is a weird number. Just because it's 3 times 3 times 3. It's a perfect cube. So don't get thrown off by 27. Don't try to read into that too much. Okay. All right, number 4 here. Now, do I have to do a factor tree with number 4 with 49? You should be able to recognize that 49 is a perfect square. 7, right? 7. Now, could I do a factor tree? Okay, well, that's real easy. There it is, done. Buddy, come out. All right, now, the hard part about this one is the x to the 5th, z to the 8th. Can somebody tell me the rule for a variable?
I guess you would go to the even number and then cut it in half.
You can cut everything in half. Cut the x in half. Cut the 5 in half, right? The 5 in half goes to 2.5, right?
Yeah.
2.5. 2, and then the 0.5 means there's one remaining on the inside. Yeah? Remember, any odd, you can kind of think of it this way. any odd power is going to have one remaining on the inside because it doesn't have an even amount of buddies, right? Every odd power is going to have one left over on the inside. Every even power is not going to have any left over on the inside. How many z's are coming out? 4. Z to the 4th. And that's my answer.
How does Z to the 4 come out?
Because there's 8, z to the 8th, right? What's 8 divided by 2?
4.
Z to the 4th.
So how did you get x squared? It's like from 5x.
Because I take 5 divided by 2, I get 2 and a half. 2 and 1 remainder.
So that's why it was inside the x.
Right. Now, you can always, guys, look at me real quick. Because people aren't realizing that you can fall back on this. Isn't that x to the 5th?
Yeah.
Do the buddy system. 2 coming out, 1 staying in. Right? Isn't this z to the 8th? Okay, 1, 2, 3, 4, 5, 8. Do the buddy system. How many coming out?
4.
How many staying in?
None.
So you can always fall back on that if you need to, but the quicker version of that is just divide by 2. Okay, let's take a look at 5. Same thing. Now, is 32 a perfect square? You may be tempted to think that that's 6, but that's not 6. If you're ever worried about is it a perfect square or not, I just did a headed in there. You can always square root it in your calculator to see, oh, that's a decimal. That is not a perfect square. I need to do a factor tree. So let's break it down. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, I've got 5 2s coming out. Well, not coming out, just 3, 4, 5. And then we got an A to the 7th and a C to the 4th. All right, let's buddy up with my 2s. Looks like I've got 2 sets of buddies coming out, which makes a 4 total on the outside. Remember, 2 times 2 is a 4 total on the outside. Now I'm going to leave some room because it looks like I've got some A's and some C's that need to come out too. How many A's are coming out? 3. 7 divided by 2 is 3.5. And then 1 staying in. A to the 3rd with 1 staying in. How many C's should come out? What's the power on C be? 2. C squared. C squared. And that's my answer. If I had to venture a guess, I would bet that the next 4 problems, 6, 7, 8, and 9, are probably the ones that you guys struggled on the most. The fraction problems. I don't know. In my mind, those are one of the more difficult types of problems. So let's go through those. And if we have extra time at the end of class, I'll be more than happy to go through a couple more if we need to. Number 6, radical 17 over 36. Now, for this one, I need to break that apart. But before I do that, I should check to see if it could reduce. Like 17/36. Can I reduce that? Well, think about 17. What can I divide 17 by? 1 in itself, right? Is there anything else? No. Can I divide 36 by 17? No. So that fraction cannot reduce. If the fraction cannot reduce, then you break it apart. Now, square root of 17. We just talked about we can't break that apart, right? If I were to try to go do a factor tree, it'd be 1 and 17. Nobody's. It stays the same. So we can leave that. That is fully reduced as it sits. What is the square root of 36? So radical 17 over 6. There's some that reduce, and then some that don't reduce. Like this one. This one reduces. Well, in the end it does. I guess I'm getting a little ahead of myself. Take a look at the two numbers as a fraction. 18/25. Does 18/25 reduce? No. Think about 25. What divides 25? Just 5 and 25. Can I take 18 divided by 5? No, it'd be decimal. So what I have to do is take the square root of 18 over the square root of 25. Now it'll break down, right? What is the square root of 25? The bottom. 5. Now, the square root of 18, that's not a perfect square. So I have to try to factor tree that down to see if it will reduce at all, which is 2 and 9 and 3 and 3. I don't know why I reordered it like that, but whatever. I've got a buddy set of 3s coming out with a 2 staying in, and that's my final answer. Okay. Questions about that? Yes.
So when you went from 18 to 25, that was only squaring like the whole thing, and then you squared both.
Yeah, and then I took them separately. Yeah, take them separately. All right, let's take a look at number 8. Is there anything that I can do to reduce the fraction on the inside? Yes. Take a look. I've got x to the 9th over x to the 3rd. What can I do to reduce the fraction on the inside?
Split in half.
Not split in half.
Actually, 30.
Don't divide. I'm dividing by the numbers, subtract the exponents, right? So take a look here. This x to the 9th, let me highlight it for you. This x to the 9th over x to the 3rd. That will become an x to the 6th. You cannot forget about everything that we've learned previously in the year. Exponent rules. Whenever I'm taking two exponents and I'm dividing them, I have to subtract the exponents, right? So if I'm dividing the bases, I subtract the exponents. Oh, wait, sorry. That x to the 3rd should be gone from the bottom. Sorry about that. Once you subtract it, it goes away from the bottom. Erase that if you wrote that. All right, now it's reduced. Now I can start taking the radical, which means I've got the square root of x to the 6th over the square root of 64. What is the square root of x to the 6th? X to the 3rd. Divide by 2. What is the square root of 64? 8.
So whenever it's like an x in front of it, you just divide the exponent by 2.
That's the rule. Yep. Yes.
I got the same. Sorry, my voice is.
That's okay.
I got the same answer, but I didn't even know that was x to the 9th. I literally thought it was x to 9, but I still ended up getting the same answer, like x to the 3rd somehow.
That might have been just coincidence. Be careful with that.
I don't know.
Okay, take a look at number 9. Take a look at number 9. Now, I'm going to do 9 in two different ways. The first method is the one that I would use. The method that I would use is to reduce now. Like, for example, just like what we did a second ago. What is a to the 7th over a to the 3rd? A to the 4th, right? We subtract. So it's going to be a to the 4th on the top. Okay, now, take a look at the numbers. 20 45ths. 20 45ths. What can I reduce the top and the bottom by? 4 9. What did I divide by top and bottom? 5. Right? Divide top and bottom by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. So 4 ninths. You can also just put it in your calculator and hit the fraction decimal. Put it in simplest form for you. All right, now in that case, now I'm going to take it apart. I'm going to say, okay, 4a to the 4th over 9. Square root of each one of them separately. So what is the square root of 4a to the 4th?
2 over 3. Wait, would we choose the a?
Yeah, well, what does that a become?
A squared.
A squared, yeah. 2a squared over 3. And that's my answer. Okay, I'm going to show you a different way. I would not do this route, but some of you, I bet, started this way. Reduce later. I don't love this, but whatever. Take them separately. Okay, like for example, the 28 to the 7th. Okay, 20. 2 and 10, 2 and 5, right? So 2 times 2 times 5, and then 8 to the 7th. Buddy up with my set of 2s, and that would be 2, and then 7 divided by 2 is 3. A to the 3rd with a 5a staying in. Yuck. 45, that's 5 and 9 and 3 and 3. So 3 times 3 times 5 with an a to the 3rd. Buddy up with my 3s, which would get me a 3. 3 divided by 2 is 1.5, so a to the 1st with a 5a left over. What do you notice about the 5a's? They will cancel, which would leave us with something that looks close to our final answer, 2a to the 3rd over 3a. And then you would subtract those. Well, 3 minus 1 gets us a squared.
That is so dumb.
I know, but that's why I stress the reduce now version.
Do you want it every question that we have a fraction?
I would rather have you reduce now. But people like to just see the square root and they try to break it apart. Don't break it apart until it's fully reduced. Okay, take a look at 10. Pretty easy question. One of the easiest ones on here. Sid? 10 radical 5, you mean?
Yeah.
Yeah, 10 radical 5. Good, yeah. Common radical terms, just put them together. Keep the same radical. What about 11? Nathan?
9 radical y.
9 radical y. Good. Remember, I have that one on there so you remember that there's a 1 there, right? 10 minus 1. Can I add 12 as it sits right there? Nope. Break it down. Break down 48. That's 2 and 24. 2 and 12. 2 and 6. 2 and 3. Which is 4 2s and a 3. Buddy. So we got 2 2s coming out with a 3 staying in. And then 27. That's a 3 and a 9 and a 3 and a 3. So plus 3 times 3 times 3, which is 3 radical 3. Now can I add them? Yeah. 4 plus 3 is 7 radical 3. Questions on that one? Again, you're finding here that if you know how to reduce radicals, if you've put in the work to reduce radicals, this stuff is easy peasy. Take a look at 13. Now, the only difference between 12 and 13 is that there's a number in front of it, right? That there's a number in front of it now. Okay? Same rules apply. Break down 18. 2 and 9, 3 and 3. Do not forget about the number in front. 2 times 3 times 3. I buddy up with those 3s. Yeah. Don't forget the number out front is the whole number 3. I'm bringing a singular 3 out, so 3 times 3 gets us 9. 9 radical 2. Break down 50. 2 and 25. 5 and 5. Okay, do not forget about that 6 out front. It's a very common mistake. Don't do it. Buddy up the 5. Now, what should be total on the outside? 30, right? Minus 30 radical 2. 9 minus 30 is negative 21. Again, you're finding the difficult part about this is reducing the radical, not the addition or subtraction.
We do number 15.
We're going to do both of them. Don't worry. We got 3 minutes left. Now, what's the difference between 14 and 12 and 13? Nothing. There's just 3 terms. 108 is 2 and 54, which is 2 and 27, which is 3 and 3. So 4 on the outside, 2, 2, 3, and 3. Oh, 3 and 9. Whoops. And then 3 and 3. There we go. One more 3s. That's a lot of 3s. Buddy up. 6 total coming out with a 4 already out there. That's a 24. Radical 3. And don't forget the x that's still in there.
Wait, how is it 6 going to come out?
2 and a 3 coming out. 2 times 3 is 6.
I keep forgetting you don't add them.
Yeah, multiply. 3 and a 9, 3 and a 3. So that's plus a 3 times 3 times 3x. Bring that out. 3 radical 3x. And then 75. 3 and 25. 5 and 5. Please don't pack up. That's really annoying me. You still got 2 minutes left. And then we have the 5 coming out. Oh, don't forget about the 2 that's already out. So we have a 10 radical 3x. 24, oops. That's a minus there. 24 plus 3 minus 10 is 17 radical 3x. Now, how do I find perimeter? Add the 3 sides. I add 8, 5 radical 2, and radical 8. The only one that breaks down is radical 8. 2 and 4, 2 and 2. So that becomes a 2 times 2 times 2, buddies. So this becomes an 8, a 5 radical 2, and a 2 radical 2. 8 plus 7 radical 2. Can I make that a 15 radical 2?
No.
No, you cannot.
That's like x plus 8.
Right. Okay. Again, I'll be posting that video if you need to see any part of that. If you missed any of that review, it will be up.